Welcome to General Structures 2 and Lateral Forces, Lesson 2 quiz, question number 9. We're just going to go ahead and jump in. It says, how does a cable respond to changing loads? We have A, B, C, and D. So we have a cable. Let's say a cable looks like, oh, let's say it's just attached to that, and it's down like this. And A says it develops bending moments, and a cable cannot develop a bending moment. If you look at a little piece, you can go to infinitely small, but we'll say just a little piece, where it's getting so small it's kind of like a straight line, but obviously it's not. So you have tension, and you have tension, and that's what your assumption is for your cable. It's tension only, and it's not like a truss where you can get tension and compression in real life. And it's not, it's kind of like the opposite of an arch. Arch, you can develop some bending because of the structure that's used. These, you really assume we cannot develop any bending in this stuff. Like if you look at an arch, your arch will develop slight bending, but this will be tension only. So if you try to develop bending, this cable is just going to bend. Alright, so I think it develops bending moments. We just determine that's a no. It will not develop any bending moment, because if you bend it, well, it's just a large wire. So if you bend that wire, it's just going to bend. It might have, infinitesimally small amount of resistance against bending moment, but it's not going to be noticeable, and you definitely want to neglect it in any design. Alright, going on. B, it assumes the shape of a catenary. And that's not the easiest thing to kind of understand of the catenary versus the parabola. But what the difference is if you have this may not be the best example. Let's use a symmetrical example where it's hanging down. So with absolutely no load, this is going to produce a parabola. And if you load it like this, just uniformly, you will end up getting a parabola. And that's parabola. Now if it's uniformly distributed along the length of this cable, like so, then the shape that will produce is a catenary, or however you pronounce it. I don't use that verbiage too very often, so, but that's the big difference. So in this case, it says it assumes the shape of catenary, and that's not necessarily true. How does a cable respond to changing loads? I would say that is not true, given that definition I just gave you. So we'll cross it off and we'll move on. It develops tension, changing loads. Well, it started in tension, it ended in tension, so not best answer. But yes, it will be in tension, but it's not like that was any different than it was before. So let's look at D. It changes its shape. I think this is the best answer. It changes its shape, because what will happen? Let's just think about it logically. You drop a big old load, like just almost infinitely large, but obviously not infinitely. But what that will do is that will push this down to be like that. Obviously that's not the best drawing in the world, but you understand what I'm doing. It will change the shape of that cable. So D is going to be your best answer, and I hope that helps. What I would do, it doesn't seem like there's going to be a lot of cable type questions for the example, so I would go back and go through, make sure you read through this chapter. It's important. You don't have to take a huge thing, a lot of information away from it, but it is worth looking through, and this gives a good basis on what your arches are, your cables, your trusses, your all the different types, your arch, your ribbed arch, your whatnots. So this is a good basic general layout of what the different types of structural systems are.